Hello, I'm going to go over this worksheet, Basics of Lewis Structures. And it talks about Lewis structures here, but Lewis structures are a way of drawing out the outermost electrons so we can track where they go during a chemical reaction. So I'm going to show you a couple things on the worksheet. We've got our element. We're going to draw out an atomic structure, which you've seen before. That looks like these here. These are like the atomic structure. It shows all of the electrons. So we're going to draw that out, but then we're going to draw the Lewis structure, which looks like this. And that one only has the outermost or valence electrons. So let me walk you through it. If we look at helium and we look at our periodic table, helium, how many electrons does it have? Well, helium, the atomic number is 2, so it has 2 protons, which means it will have 2 electrons. So you don't have to put this, but this is just so I remember, it's 2 electrons. The atomic structure for helium, and we're not going to do the nucleus, we're just going to do the electrons. We've got an orbital, there's 2. This first orbital can hold 2 electrons total. So 1, 2. Now this first orbital is full. Okay? We're going to draw the Lewis structure. This is its outermost orbital. These are the outermost electrons. So drawing the Lewis structure is pretty straightforward. He again, and we'll put 1 here and 1 there. So 2 electrons, 2 electrons. But we should do some more complicated examples. So I'm going to go down to the next one, which is carbon. Carbon is number 6, so 6 protons, which also means it has 6 electrons. I'm just making my notation there, reminding myself that there's 6 electrons. Atomic structure, we'll put carbon, and we draw our first orbital. Same 1, 2, just like helium. But that's all that orbital can take. It can't take any more. So we have to go to the second orbital. We draw another circle. And you see these multiple circles back here, right? Oxygen has multiple circles. Sodium has 3 circles. These are the orbitals. So I need 6. I've got 2 already. So now I'm going to do 1, 2, 3, 4. Because this second orbital can hold up to 8 electrons. So I can put up to 8 here. And we'll see in a moment how that looks when we do that. So now the Lewis structure for carbon, I'm only drawing that outermost orbital. Just these ones, not the first one here. So that means it's going to look like 1, 2, 3, 4. Right? 1, 2, 3, 4. All right, let's do one more on the next page, because this definitely can be complicated at first, or confusing at least. And what we're going to do is we're going to do this last one, chlorine. Chlorine is all the way over here on the periodic table. Atomic number 17, so 17 protons, 17 electrons. Just a little note for myself there. So, atomic structure of chlorine first. Well, first orbital holds 2. Next orbital is going to hold up to 8, but I'm going to do it like this. 1, 2, 3, 4, and then we're going to pair all of them. 5, 6, 7, 8. So now that one, second orbital is now full. It's got 8. And I'm only up to 10 total electrons, so I need another orbital here. And this one can also hold up to 8. So 10, I need 7 more. 1, 2, 3, 4, 5, 6, 7. And what you'll notice is there's an extra unpaired electron here. That'll be important for later on. Not in this activity, but in future activities. So now my Lewis structure for chlorine, remember I'm just drawing this outermost layer, this outermost orbital. So I'm going to do, and that one has 7 total electrons, right? So 1, 2, 3, 4, 5, 6, 7. That's the Lewis structure for chlorine. Okay, if you have any questions, please let me know, and I will try and help you out. Thank you very much.